Good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. I am teaching you the physical special paper of chemical dynamics of M.SC final. Yesterday we have studied about sequential method and a non-sequential method and sequential method of kinetics for reactions, which are inhibitors and catalysts. Today we are going to study the kinetics of sequential mechanisms. Mechanism of sequential model is given by, as you see in diagram, E is a reactant enzyme with K1 rate and A substrate or reactant. It is by equilibrium reaction, it is converted into EA. Then with K3 and reactant concentration B, it EA combines this with a K3 forward reaction and K4 backward reaction, and it forms EAB or EPQ. We can say both are true. Then EAB or EPQ with with K5 rate constant converted into Q. Okay? And this with K6 rate constant again converted into P. This is also reversible reaction. Now Q, which is also converted into K7 rate constant to E. From Q and E, Q is separated as a product and E is regenerated by K7, and by K8 Q is again added to enzyme. So this is a cycle how enzyme is converted into product and product is converted into enzyme. K into concentration of A or formation constant is known as formation constant, and small ka is known as ionization constant of acid. Considering microscopic reversibility, the kinetic rate law for this mechanism can be derived. The double reciprocal form of rate equation is given by following equations. 1 upon R is equal to Ka upon R maximum, and this is given by 1 plus K dash Kb upon Ka into concentration of B, bracket closed, again multiplied by 1 upon concentration of A, plus 1 upon R maximum in the bracket 1 plus Kb upon concentration of B, where R is equal to initial rate. R maximum is the maximum initial rate, that is the rate becomes independent of the concentration of the substrate in the rate concentration profile. There is difference. R is initial rate of the reaction and maximum rate is the rate at which rate become independent of concentration of the substrate in the rate concentration profile. Concentration of A is equal to represented by concentration of A. Concentration of B is represented by concentration of B. Ka and Kb are the acid. These are the ionization constants of acid and base. From this equation, it is clear that the rate can be correlated to the concentration of either of the substrates, that is A or B, and then value of various constants involved in the rate equation can be evaluated. Ka and Kb are ionization constants of acid and bases, and this equation it is clear that rate can be correlated to the concentration. Rate is always, most of the time, is correlated to the concentration of the reactant, either A or B. Rarely when the rate constant is 0, it doesn't depend on concentration. Rate of reaction either of the substrate and the value of various constants involved in rate equation can be evaluated. Now, two type of situations are possible. First, when concentration of substrate B is kept constant and the concentration of substrate A is varied. Concentration of B is kept constant and A is varying. In that situation, a plot of rate 1 upon rate against 1 upon A will be a straight line with intercept with intercept. ठीक है, 1/r 1/a में we have plotted a graph with the intercept. It is a straight line with the intercept of we have not given points a or b or this. The slope and this intercept can be written for this equation. We can write equation for this direction. Secondly, similar treatment can be applied to the rate equation by rearranging it and keeping constants the concentration of A, varying concentration of B. In this case also, a plot of 1/r 1/1/b will be given by a straight line with positive intercept of 1/r and 1/b. The line where this straight line cut the y-axis is known as intercept. That is, it is a sequential mechanism, as this plot is a characteristics. This is the characteristic of plot which is sequential. Secondly, kinetics of ping-pong mechanism, non-sequential. The rate mechanism is given by as E with a rate constant K1 and A is converted into EA. With a rate constant K2 it is converted, can be converted into E again. This EA or EP with K3 and K4 rate constant, they are interconvertible into E, and with rate constant of K4 it is converted into P. Next, E is again with rate constant of K5 and concentration of B, and rate constant of Kc can be converted either into E or EB or EQ. EB or EQ, these are the products, and they again with the rate constant of K7 and K8 and concentration of Q again converted into E. They are again converted into Q. The kinetics rate equation is derived by considering microscopic reversibility. This reversibility is not macro type, just which we can derive concentration, calculate them. It is microscopic reversibility. The double reciprocal form of such a rate equation is given by following equation. 1/r is equal to Ka upon R maximum into 1 upon concentration of A plus 1/r maximum bracket 1 plus Kb upon concentration of B. This is equation number 2. All the terms, you can compare this equation with equation number 1, where their जो terms हैं first and second, they are interchanged. ठीक है, this similar type of equation is also there. All the terms involved in this equation have usual meaning as in equation 1. This equation has rearranged in such a manner that the two variables, that is rate and concentration of one of the substrate, can be correlated, provided with concentration of other substrate is kept constant. This will provide us the experimental characteristics of ping-pong mechanics. Let us take equation 2 and keep the concentration of A constant, of B constant. A plot of 1/r and 1/a will give a straight line. It will give a straight line. If variation of A is made at different but fixed concentration of substrate B, the straight line as indicated in the following figure are obtained. 1/r and 1/a graph is and B concentration is kept constant, but B is greater than B2, B2 greater than B3. It depends on the substrate concentration. Fixed but different. Difference between sequential and non-sequential or ping-pong mechanism is that in case of sequential mechanism, at different but fixed concentration of B, we get different intercepts and different slopes, as is clear from figure 1a. Just see the figure A. If we change the concentration, if we change the concentration of B, it will be the B1, B2, B3, but it is fixed, And under such conditions, if we obtain graph between 1 upon r and 1 upon and we get different slopes and different intercepts for different percentages. In case of ping pong tennis, we get different intercepts but similar slope as we have found before. The slope is same but their different intercepts are different. Thus, ping pong mechanisms give only intercept effect, whereas both intercept and slope effects are observed in the sequential kinetics. समझ में आया बच्चों? We have studied about two type of kinetics, sequential kinetics and random kinetics. Sequential, non-sequential, random we have studied in the last chapter. So you can see that there is difference between sequential and non-sequential